Hello, welcome everyone to question number 8, count inversions from the topic arrays in Geek for Geeks must do coding interview questions. Just have a quick look at the question. I will be discussing the meaning and the approach to it. Before that, please don't forget to hit the subscribe button. If you have any extra email IDs, please do subscribe with that. And if you have any doubt, just leave a comment down where you are facing the problem. We will be very quick to respond. Now let's understand the meaning of this question. Here in this question, it's saying we have to count the inversion. Okay, we have to count if the left side element and right side element is not in ascending order. Okay, so and we will be discussing that how to count the variables. Okay, for that now we have to follow the merge sort here. We will be counting the number of inversions while using the merge sort, and you will understand what is the count inversion after some time. Till that, follow through this video. In this question, 2 4 1 3 5 have is given. Now if you follow the merge sort, we will be dividing this in two parts. Okay, first part will be 2 4, this one, and second part will be 1 3 5, and both of them will be divided in left and right sub arrays. Okay, left and right sub arrays, and we'll be using left and right sub arrays for comparison. Okay, now we have to break each of the boxes into a single individual value. Okay, and we'll keep on dividing till we get a single individual value. So here we got 2 4. Now we divide it, and the priority is we have to divide all the left side values, then we divide the right side values. Okay, so we're going to check the left side box, which is 2 4. 2 and 4 has been divided separately. 2 will be our left side value, right? 4 will be our right side value. Similarly, now coming to the right side, we have divided this 1 3 5 in separate boxes. 1 and 3 5, and 3 5 has been divided again 3 and 5. Okay, and visually you can say we had divided each by step by step manner, but what is actually happening is we are using the recursion here. Okay, in recursion, remember, it always starts from the deepest part of the or example here. In this case, the deepest part is the last value, which is 2 here and 4 here. On the right side we have 3 and 5, and we have two recursion calls. One is for left tree, or not tree, you can say left side values, and other is for right side values. So coming to the left side values is one recursion here. Now every time a recursion comes, now we have to compare them. Okay, first we have divided the values. Now we have to compare those values. Okay, if these are in ascending order or not. If it is not in the ascending order, then we make them ascending order. Okay, now coming to this 2 and 4, 2 is smaller than 4. Yes, it is perfect. So 2 and 4 is valid here. Now left side part has been completed, and you also have to check the level is same or not. Okay, we are going to compare left and right side at the same time. Okay, now left side part has been completed, right? At this level, the left side part has been completed. Now we have to complete the right side part also further. Okay, to complete this part, we have to complete the below value for that. Okay, now I have mentioned that in the recursion part we have to complete the deepest meaning first. Okay, deepest part is 3 and 5 here. Is 3 smaller than 5? Yes, and it will recombine itself into 3 and 5. Now 3 5 and 1 is there. 1 is smaller than 3 and 1 is smaller than 5 also, no problem. Then we combine it again here. Now we are at the same level. Now we got 2 4 and 1 3 5. Same thing happens, we have to compare similar manner only. Now just treat this as one left side entity and treat this as one right side entity. Okay, now if any value doesn't satisfy the condition that left side element should be smaller than the right. Okay, if it doesn't satisfy, then we add it into a new array, and that will be our final array consisting of ascending order. Okay, now let us assume that variable as d. Okay, now we have to compare left side value. First left side value will be starting from this. This is 0 index, 1 index, and in this question also this will be our 0, this will be 1, and this will be 2. Okay, now these are two recursion as I mentioned, and we're comparing both of them at the same time. Here is 2 smaller than 1 or not? No, it is not smaller than 1. The condition is wrong. So what we're doing is here there is one pointer, name it y here, and name this pointer as x here. Now x is at the position 0, y is at the position 0 from the right side. Okay, now the condition is false here. So what is happening? So we just add this one element here. Okay, we added one element to a list of t here. Okay, now we are updating the value of y here. Now y comes to the index 1 here. Now y is at index 1, and we have added this 1 value to this. Okay, 1 is smaller than 2 and 1 is also smaller than 4. So that's why we have added here. Remember, the condition says the left side value should be smaller. Okay, if it is smaller, then we add the left side element. If it is the left side element is not smaller, then we add the right side element to the list here. Okay, now one we have added one now. Fine. Okay, now there is one more thing I would like to mention here. We also have to count the values here. Okay, now we have added one here, right? But see how many of the values are greater than one on the left side. There are two values here, but we are only comparing the left side value here. Why we are doing that? Because the right side values in this array are automatically greater because we have already sorted it using the merge sort here. So we just compare the left side element, left side minimum element with the right side element. Okay, if it is false, then we have to take the length of the remaining elements. Okay, the length of the remaining elements we have to count. Okay, now let us take a c variable here, and now count will be updated by 2. Why 2? Because 1 is smaller than 2 and 1 is also smaller than 4. Okay, 1 will be going here now. Okay, now 1 is here, 2 is here, 4 is here, right? 1 to 4 is there because 1 is smaller than 2 and 4. So it is 2 elements ahead. So we have updated the value of count by 2 here. Okay, now after that y is updated to the second index here, which has a value 3. Now we have to check similarly, is 2 smaller than 3? Is 2 smaller than 3? Yes, 2 is smaller than 3. Then we just append it to the new list here. Now 2 is inside this box. Okay, good. Now if the condition 2 is smaller than the right side value 3, then we update the x value here. Okay, now the x index is at this position now. Now we are only remaining with 4 element on the left side. Okay, now again it's 4 smaller than 3. No, it is not. So if the condition doesn't satisfy, left side element is not smaller than the right side element, then we append the right side element to our new list here. Now we got 4 here. Now y value index will be updated to the y value here. So index will be 2 for the y pointer here. Now again we check, is 4 smaller than 5? Yes, it is smaller. Then we just add 4 here. Okay, after that we check if any element is remaining inside the either of these boxes. In this left side 2 4 have been appended, so no element is remaining. In this side 5 element is remaining. If the elements are remaining, we have to add them. And also remember, we have to update the count value here. Okay, here I told that 4 is greater than 3, right? 4 is not smaller than 3. So here the condition was not satisfied and we have to update that value. That will become 2 plus 1. So our count will be 3 here. The inversion count will be 3. And this is the value that we have to get. Okay, I hope you have understood the meaning of the question. If you still haven't understood what are the inversion counts, then let's go to the coding section. I hope after watching the code you will be having a clear idea. Now here we are inside the coding section part here. Okay, and as we mentioned, we have to take a count variable here, and there is an array which was given to us that will be 24135 as we have discussed. This is the example that we got, right? That's the same example that we are going to use for this. So we got 24135 inside the array, and count we have initially given 0 as a value. Now it is calling the merge sort function. Remember I told you that in merge sort we will divide the elements till we get a single individual level, right? Now if length of array is equal to 1 or length of the array is equal to 0, then we simply have to return the array. Okay, if it is greater than 1, if length is greater than 1, then only we can divide. If the length is 1, we cannot divide, right? So that's why if the only one element we are having, we just simply return that one last element. If the length is greater than 1, then we divide it in two parts, left and right side part. And here left part is calling its own recursion and right side part is calling its own recursion. We have discussed in the previous presentation also that we are going to divide the left part separately, right side part separately, right? Both of them are using the same function. We'll be dividing the whatever the array is there, we will be dividing those in half. In each recursion, it will be divided into half and half part till we get a single individual level. Okay. After getting those single individual levels, we are using those arrays inside the merge function. This is another function. In this function, we are going to sort the elements. Okay. In the first merge sort function, this function, here we are only dividing the elements in this function. Okay. After dividing the elements, we are rearranging those elements inside this function and also counting those elements here. Okay, now coming to the other function here, merge function, we have taken two pointers. Okay, I also mentioned this in the presentation, x and y pointer in that, but here we have used I and j. Okay, these are the two pointers here. The condition will be I must be smaller than length of the left array. Okay, this I variable is used for the left array and this j variable will be used for the right array. Obviously, if the index value is greater than the left array or the right array for j, that means we have already iterated all the elements, right? So that's why we are using this condition so it doesn't go out of bounds. Okay, and in this question that we are given, if left array is greater than the right side array, then only we will use the count here. Okay, we haven't used the count in this because the question is only asking if the element is greater. Okay, if it is smaller, then the left array will be appended to the final list here. If it is greater, then we also count. Along with counting, we also append the right side element here. Okay, you may have a doubt here what is happening. This is the count initial value plus the current value. Okay, and I mentioned this part very thoroughly. This part I told that if the leftmost element is greater than the right side element, okay, then it automatically means the whole left array is greater than the right side array, right? So we're taking the total length here. Yeah, how will we get the total length of the remaining element is you have to take the length of that left side array and minus the current index. Okay, if we minus the current index, we get the remaining elements value. Okay, that is what happening here. We will get 2 in one case and we get +1 in another case. We get 3 value at the final output here. Okay, that will be this one. Okay, 3 output. Okay, now after that we are checking in other two while loops here if any element is remaining. Okay, if any left side array element is remaining, we just append it, and left side array is the first priority in the merge sort because in the left array only we are storing the smallest values. Okay, that's why we are checking the left side as a higher priority. Okay, after left side we have appended, then we check for the right side element if any elements are there or not. If there are elements, then we simply add those in the final list here. Okay, and this final list will be containing the merge sort, and that will be 1 2 3 4 5. Okay, this final value has 1 2 3 4 5 as a value, and this count will be containing 3 as a value. Okay, after merge sort and merge have been completed, we will return this value. Okay, we will return this value. Then after returning that value, the count value have been updated, right? After using both functions, the count value have been updated. So count value here is a global value, as you can see. Okay, so count value will be also be updated after the statement has been completed. So next return we get the count value as 3. I hope you have understood the question after this. I hope you have understood the question till this point and also have understood the code. If you still haven't understood the code and the meaning behind the question, just leave a comment below where we can improve our video. And if you like the video, please give us a like and also subscribe our channel. If you have any extra email IDs, please do subscribe. That will be very helpful for our growth of the channel. Thank you for watching till the end. Let's meet in another question.